Hi everyone, welcome back to my channel. Whether you are a student, researcher, data analyst, or just someone diving into statistics, one thing that can easily trip you up is deciding between parametric and non-parametric tests. These two categories are fundamental to how we analyze data and draw conclusions. But how do you know which one to use? What is the difference? And what happens if you use the wrong one? In this video, we will explore what parametric and non-parametric tests really are, the key differences between them, real-world examples of each of them, and when and why you should choose one over the other. Let's break it down. Let's start with what statistical tests are. First of all, what is statistical test? A statistical test helps us make decisions about data. It lets us answer questions like, is there a difference between these two groups? Is this effect real, or is it just by chance? Does one variable predict another? To answer those questions, we choose a test, and that test must fit the type of data and assumptions we are working with. Let's begin with parametric tests. What are parametric tests? Parametric tests are based on assumptions about the underlying distribution of the data, usually assuming that it follows a normal bell-shaped distribution. Another assumption of parametric test is the data must be in interval or ratio level. That is, it has to be in continuous measurable values. For example, like height, weight, temperature, those are data at interval or ratio level. And that is the type of data that can be used with parametric tests. Another very important assumption of parametric tests is independence. Observations should not influence each other. So when these assumptions are met, parametric tests are considered more powerful, meaning that they are better at detecting true effects. So remember the assumptions of parametric tests: normal distribution of data, very important; continuous data, that is, data must be in interval or ratio level; then homogeneity of variance, that is, groups should have similar variability; and then we talk about independence, observations should not influence each other. Examples of parametric tests include t-test, whether independent or paired sample t-test. We also have ANOVA, which is called analysis of variance. We also have Pearson correlation, and then we have linear regression. For example, let's say you want to compare the average blood pressure between two groups. If your data is normally distributed and meets the assumption, t-test is perfect. So this is what parametric test entails. Let's proceed to non-parametric tests. What are non-parametric tests? Non-parametric tests do not require data to follow a normal distribution. In fact, they work great when your data is skewed or not normally distributed. And also, it works best when your data is in ordinal or rank level, like satisfaction levels when you are carrying out survey, where you have things like poor, fair, good, excellent. So that is in rank order. Also, you use non-parametric tests when data is in nominal level, like categories, male or female, yes or no. Categorical data are used with non-parametric tests. And also when sample size is too small to check for normality, you make use of non-parametric tests. Usually in parametric tests that we talked about earlier, the sample size has to be 30 and above, but in non-parametric tests, a smaller sample size flies. So that is it about non-parametric tests. Let's look at some examples of non-parametric tests. Common examples of non-parametric tests include Mann-Whitney U-test. We have Wilcoxon's sign rank test. We have Croster-Wallis test. We have Spearman's rank correlation. They call it Spearman rule. And then we have Chi test. A practical example of this is if you are comparing customer satisfaction rankings between two stores. Mann-Whitney U-test is more appropriate than t-test. I hope you got the differences between parametric and non-parametric tests. Let's compare parametric and non-parametric tests. What are striking comparison between these two types of tests? If you have to compare parametric and non-parametric tests, what are the key differences to identify. Parametric test, as we said earlier, it assumes normality. There is a normal distribution of data. And then we talked about the fact that the data has to be in continuous form. That is talking about interval or ratio level. And parametric test is also more powerful than non-parametric test because higher assumptions are met. Now, non-parametric test, no normality is observed. There is no normal distribution of data assumed. And we talked about the type of data used with non-parametric tests, which are ordinal or categorical data, and it's more flexible. So those are striking differences between parametric and non-parametric tests. How do we choose the right test to use? Use parametric test if your data is in continuous form, which is interval or ratio, and your sample size is large enough, typically greater than 30. Also, when we have homogeneous variance, we have check and confirm normal distribution, and variances between groups are similar. When do we use non-parametric test? We use non-parametric test if your data is skewed or not normally distributed. Also, when you have ordinal categorical variables and your sample size is small. And also when your data has extreme outliers that can distort results. I hope you get it. Let me give you a very important tip. Always check assumptions first. If your data violates them, don't force a parametric test. Switch to a non-parametric test for better accuracy. Do you get it? So this is a very important tip you have to take note of. Check assumptions first. That's the first thing to check. If your data violates them, then don't force a parametric test. Switch to non-parametric one for better accuracy. Let's quickly look at real-world applications of parametric and non-parametric tests. One of the important applications is in medical studies. That is clinical versus rank symptoms. Use parametric tests for clinical measurements and non-parametric tests for pain scales or ranks. Another real-world application is market research. Use non-parametric tests for customer preferences or brand rankings. Another application is in psychology. Let's say attitude scores. Use non-parametric tests when measuring feelings, attitudes, or behavior scores that are ordinal. Choosing the wrong test can lead to incorrect conclusions. That is why it's critical to match the test to the type of data and its distribution. In conclusion, parametric tests are powerful but requires assumptions. Non-parametric tests are flexible and robust. So always assess data before choosing a test and let the data guide the method that you will use, whether parametric or non-parametric test. I hope this video has helped you. You have gotten understanding about the differences between parametric and non-parametric tests. If this video has helped you understand these differences, please, you can give it a thumbs up, you can share it with your fellow learners, and subscribe for more practical statistics content. If you have any questions, drop them in the comment section. I will be happy to explain with examples or even show how to run this test in softwares like SPSS or Excel. Thank you once again for watching the video. See you in our next video.